Seeing if you guys remember what we talked about yesterday. So, what kind of line is that I just drew right there?
Bisector.
Perpendicular bisectors. Okay, and if I draw all of them, where do they meet at? Circumcenter, because it happens to be the center of a circumscribed circle. Okay, circumcenter is the center of a circumscribed circle. Also, we know that it's no, that's the other one. Sorry, I messed up. All right. Anyways, and then we also did
Altitudes, which then will where they meet.
no, that was that one. Okay. All these distances from the vertices should be the same.
Okay. The altitudes where they meet.
Altitudes, yeah. Altitudes are lines that are basically used to measure the height of a triangle. So this would be its height, or if I turned around, this is the ground, this would be its height, or that would be its height. They're all like 90 degrees, but they don't split the side in half. Okay, altitudes meet at the orthocenter. And then today we got two new ones to add on. There are four altogether. We got two new ones for today. Actually, before I do the new ones, I should do okay. If these two angles right here are the same, what kind of thing is this? It's an angle bisector. Yesterday we talked about a segment bisector, perpendicular bisector, segment bisector. This is an angle bisector. It splits the angle into two equal little angles. Ray BC bisects angle ABD. Okay, that's what it is. If we have an angle bisector, guess what I know about any point that's on the angle bisector? Call it F. F has to be equal distance from both sides of the angle. Like the distance from here to here is the same as the distance from here to here. Any point on an angle bisector is equal distant from the sides of the angles, from the sides of the angle it bisects. It kind of makes sense, right? If you like go right down the middle, any point on this line is going to be the same distance from the sides. Okay. In a triangle, if you draw angle bisectors on all the vertices, notice that's not quite in the middle. I know it's close. If you draw a equilateral triangle, it will be right in the middle. But these are not. If it's a little bit off, it should not be right in the middle. Whoops, yeah, very close. Okay. Those meet at the center. And so we know that the in-center, because of this thing right here, is going to be the same distance from the sides. Like from here to here, and here to here, and here to here. It's not really these lines right here, but there's a line right next to it. If I draw a perpendicular line from this point down, those should all be the same distance, if I drew it perfectly. All right, so that's one. The other one is a new thing. It's called medians. What does medians mean in normal life? What's a median in normal? Huh?
Like something divided.
Like a median on a highway is a what? That middle part that's kind of like a ditch or something, like from here to Tulsa. So a median goes from a vertex to the middle of the opposite side. Middle, middle, middle. It looks kind of like it is a little bit different, but on a acute triangle, they do look pretty much the same for angle bisectors median. They're a little bit off. Medians meet in the centroid. All these words, kind of hard to remember. But let's go through them. I should have wrote median down. Medians. It also means, like, it has a meaning in statistics too. It's if you have a bunch of like test scores, the person that got the middlemost scores, that would be the median. Anyway, probably shouldn't have mentioned that. So let's see what we got here. I'm going to draw the 4 things, and we'll see if we can label them correctly. I don't know if I'll draw all of them. I guess I will. Doot, doot. Doot, doot. This marker is probably about done.
Just look at the market.
3.
Like I care.
He owns you, Trevor. So I want
Which one did I forget? Okay, let's start with this one. What kind of lines are drawn on that first one I drew? Probably can't even see it. What kind of line is this?
perpendicular bisector.
Is it bisecting? Is it cutting this in half?
Oh, no, it's
Altitude.
not.
Yeah.
Altitude, that's a measurement of the height, right? Altitude. And where do altitudes meet at? This is from yesterday.
Orthocenter.
Orthocenter. I know it's hard to remember all these words. Get it? I kind of forgot them from last year. I had to review first hour. Okay, and then what kind of line is this from the vertex to the middle? Median. And where do medians meet at? Yeah, it's still on the border there. Centroid. Ooh. And let's see, what kind of lines are these? Perpendicular bisectors. Circumcenter. And what kind of line is this? Here's your hint right here. Angle bisector. Those two angles, all those angles are the same. These are angle bisectors, and they meet at the incenter. So that's all 4 together. That's the last of the 4. The reason it's called the incenter, you guys remember the circumscribed circle from yesterday, where we drew it around? If I draw an inscribed circle, the incenter should be this, it's not very good looking, but the incenter should be the center of an inscribed circle. So the inscribed circle just touches at each point. It's, you'd say it's tangent to each side of the triangle, like it brushes at one point and then just keeps going. The circumscribed circle touches each vertex. Like that. Now are we thoroughly confused? Alright. I'm just gonna do that stuff. Let's go back. Somebody drop something.
5?
Alright, we're ready to party. Oh, yeah, we'll get that later. Number 1. We're doing 1 through 18, 23 through 30. Says, name each. 1A says angle bisector. Which of those segments is bisecting an angle? YD. So you put YD with the segment symbol on top. You can tell because those little arcs around angle Y means those two little angles are the same. B, perpendicular bisector. This one's kind of tricky. So it's got to be perpendicular to the side and it has to bisect the side. It's got to make 90 degrees and it's got to cut a side in half.
B and X.
Say again. XB. Okay, XB looks like it could be a perpendicular bisector, but
Did you say?
it doesn't, we don't know for sure that BY and BZ are the same, even though they look pretty close. I think they're a little bit different actually.
Oh wait, would
Yeah.
C, A be one?
Yeah, AC or CA, yes. That is 90 degrees and it is cutting X's Y in half. Lots of
Segment
lines.
AC?
Yes, these are all segments. Altitude. So this would be used to measure the height of a triangle, right?
ZA.
ZA. Well, see how ZA is slanted towards the middle and it's not like going straight up and down like you're measuring a height? Yeah, XB. XB would be the height of the triangle. So it's an altitude. So the one we haven't used, AZ, it's going from the vertex Z to the midpoint A. So that's called a median. So AZ or ZA would be the median.
What would this chapter be called?
It's called, no, let's see what it's called. Relationships and triangles. Okay. Number 2 says name of angle bisectors. So basically all those black lines are angle bisectors. Angle bisectors, if you look at how they drew them, they are like rays. They drew them to look like rays. So your symbol on top could just be a ray symbol.
What's the race symbol again?
Huh?
Is it just arrow?
It looks like a ray. Looks like an arrow.
Look at my.
Use 2 letters to name line segments and rays. Okay, number 3. Point S is the what of the triangle. Where do angle bisectors meet? Incenter. So point A is the incenter, or sorry, point S is the incenter of triangle PQR. Because a circle with radius ST is the blank circle. It's not called an inner circle, it's called an inscribed strong inside.
So what's the first word?
It was the incenter. Angle bisectors meet at the incenter. Inscribed. Just like it sounds.
I'm bad at spelling.
Inscribe it on your memory.
I'm really bad at spelling.
Yeah, if we just don't tell anyone, we'll never know.
Kind of just tough.
Okay, number 5. If SU is 8, you guys see SU in the picture?
Yeah.
Then how long would ST have to be? 8. So it's just 8. Yeah. The incenter is supposed to be the same distance from each side of the triangle. So it's not, they're not trying to trick you, it's just 8 and 8. Okay. On number 6, it's pretty similar. ST and SV would have to be the same length. So you're going to have to do some algebra to set them up. Number 7, angle VRS is 7x minus 1. Do you guys see VRS in the picture?
Yeah.
It's in the bottom right, bottom half of that angle. And then it says, and angle URS is blah, blah, blah. Do you guys see angle URS in the picture? Bottom right angle, top half. Okay, what do I know about those two angles?
SR is bisecting.
Yeah, but what do I know about the angles?
They're equal.
They're the same. So in other words, 7x minus 1 is the same as 5x plus 5. So we need to do 7x minus 1 equals 5x plus 5. We used this trick a lot this year, right? How do we solve this if we got x's on both sides?
By getting the one side of the problem. Minus 5.
Right. Get rid of the 5x, actually. You can minus the 5, but you probably want to handle the x's first.
Well, yeah.
That's what you meant. Equals 5.
Here's a 6. Here's a 7, right?
So we just put
Is 3 the answer? Is that what we're looking for, x? No. We're looking for angle VRU. You guys see that in the picture? It's the entire bottom right angle. So how could I find angle VRU?
you have to plug in 3 again, then do
Okay, these two represent the
the
bottom
20.
angles. The little angles, the angles that are split in half. So if I plug in 3 for like this, 5 times 3 plus 5 is 20. That tells me one of those little angles in the bottom right corner is 20. So how do I find, like this angle is 20. So how do I find the entire angle? Yeah, these are the same. These are both 20. So 20 plus 20 is 40. So really it's, the answer is 40 degrees.
Wait, I have a question.
That's that name. Yep.
How do you identify a median and the radius centroid again?
A median is going to go from the vertex to the middle. So just remember middle sounds like median. Perpendicular, and they meet at the centroid, that would be right there. Perpendicular bisectors are perpendicular and they bisect, like these two are equal. I didn't mark that, but they should be. Altitude is like you're measuring the height of a triangle. But you can do that from any side, like you could rotate it and do it from here to here also. They're always 90-degree angles, so that would be the height. Angle bisectors, it's going to show these like little two angles here are the same, because it's cutting the angle in half. And then we get the incident. So usually the name is pretty descriptive. Perpendicular bisector has to be perpendicular and has to bisect. Median has to get to the middle. Altitude looks like it's measuring the height of the triangle. Angle bisector looks like it's cutting the angles in half. Now, that's probably the easier part. The hard part is remembering this goes with circumcenter, or median goes with centroid. Median and centroid both sound kind of like the middle and center, so that kind of helps. But this word also has center in it, so I don't know if it does help or not. Okay, anyway, where are we at? Lost my place. Number 11? 9? Okay, on 8, it says name the medians. Those are the three things in the middle. 9 says what's the name of point D? Where do medians meet at?
Centroid.
Centroid. So 9 is centroid. Okay, number 11, I didn't talk about this rule, but it says if BZ is 15, how long must BD be? Okay, I never mentioned this. This is kind of a weird one. I don't think this was even in the other books, but if you look at like the bottom of 216, it says centroid, the median is 2/3 from the vertex to the opposite midpoint. So in other words, BD is 2/3 of the way to BC. So how do I find out what 2/3 of a number is?
Divide by 3.
2/3, what does of mean?
Times.
So we need 2/3 of 15. You can just plug in your calculator, but 2 times 5, 10. Yeah, it's kind of like dividing by 3 and multiplying by 2. If you think about it, it should make sense. 2/3 of 15 is 10. If you think of 15 as 3 5s, then 2 of those make 10. That's number, no, number 10 is different, never mind.
No, it's 12.
12 is kind of the opposite. 12 is asking for the short side. So, if going from the vertex to the centroid is 2/3, and going from the centroid to the middle of the side is 1/3. It's kind of tricky.
Wait, so you do 1/3 times 3?
Yeah. You can kind of just look at the picture and tell, like, this is most of the way, so that's 2/3. This is part of the way, so that's 1/3. You can kind of tell just by looking at the picture. Number 10 is much easier than those two. Just look at the picture and you'll figure it out. 13, acute triangle. Okay, this is kind of what we did yesterday. Remember I drew those 6 triangles, and kind of like this, but with one acute triangle, one right triangle, one obtuse triangle. That's what we're doing now. So just go ahead and start drawing. This will be my acute, this will be my right, and this will be my obtuse. This is actually 13, 14, 15. On 13 through 15, we're supposed to be drawing the angled bisectors. So I'm just going to very carefully try to split the angles in half. Just kind of pretend like this is a cannon, just shooting it out right through the middle. And if you do it right, they should meet at a point. I'm not going to be super picky, but I still might count some of these wrong. I mean, that's like that was too sloppy. Like if your lines don't even meet at any point, so I'll count it wrong, or if they're just really bad, I'll count it wrong.
This is 13, 14, 15.
Yeah. So all of my lines that I drew here are just angle bisectors. I'm just trying to draw the line right down the middle of the angle. And if you do it right, they meet at one point. That was actually 13, 14, 15. So on 16, 17, and 18, the same thing. We were supposed to draw.
We have to label the inside.
Yeah, it did say to label the incenter with an I, so I guess you put a little I right there is fine on all those. Same thing. We gotta draw the 3 kinds of triangles: acute, obtuse, and right. But on this one, we are drawing the medians. So this should go from the vertex to the middle. Vertex to the middle. Vertex, middle, vertex.
Is that 16, 17, 18?
Yeah. Vertex, middle. Median equals, whoops, median equals middle. Ah. It should be in a slightly different location than the. Can't draw a straight line in this. Slightly different location than the angle bisectors were. Unless you draw like isosceles triangles, which is kind of hard not to do. Yeah, ugly.
Or do you do, like, Hebrews?
Let me find out who's missing.
That's better.
Thank you. Done.
Finished?
Yep.
Alright, I don't hear any complaints. So 23 says, does BF equal, are you guys on the next page? Does BF equal DF? Okay,
Yes.
why?
Because
No.
the angle bisector. So
Because F is, yes, because F is on the angle bisector. So it has to be equidistant from the sides. Yes, because F is on the angle bisector. So it has to be equidistant from the sides. Okay, on 24 it says CF and G are collinear. Are they collinear? How do we know that G is on the same line as C and F?
The two AG and EG are congruent.
Okay. Because G is equidistant, which means equal distances, from the sides of the angle, it has to be on the angle bisector. Because G is the same distance from the sides of the angle, it has to be on the angle bisector.
Okay. This 24, right?
Yes.
Can you say it one more time?
Because G is the same distance from both sides of the angles, it has to be on the angle bisector.
Would you just say G is equidistant from the angle sides?
No.
That's too easy.
So what I should have.
So it's on the angle bisector.
Got it.
All right, 25 says angle ACE is 70. Do you guys see ACE in the picture?
Yeah.
It's kind of that big angle in the corner. So we're supposed to find angle CFD. CFD. Do you guys see angle CFD?
Yeah, and I got the answer.
Okay. If ACE is 70, what would angle FCD have to be? Half.
35.
35. Is 35 the answer?
No.
No. Okay, but it helps us find the answer. So basically, we're looking for this angle right here, but we just figured out that this angle is 35 because it's half of 70. So if we got 35, 90, how do I find that guy?
Add those two, then subtract it from 180.
Right, 180 minus 90 minus 35.
Or 180 minus 90 minus 30, yeah.
55. All right, 26 is not too tricky. I think you guys will figure it out. 27, angle AGE. Do you guys see that one in the picture? It's the big one on the upper right. Angle AGE is equal to 130 degrees. Find angle ACF. Okay, well, if you extended a line through FG, you guys see what I'm talking about?
Yeah. Looks like it'd be cut in half.
Yeah, it'll be cut in half. There's a couple ways to prove it, but yes, it would be an angle we know it's on the angle bisector, right?
Yeah.
So that 130 degree angle would be cut in half. So what would each half have to be?
65.
Yeah. So I kind of drew that wrong. It looks kind of like that 65. That would have to be 65 if we extended that line. But we're actually looking for this angle right here, kind of like the last one.
Yeah.
So how do I find it?
You.
Second thing.
180 minus 90 is 90. 90 minus 65.
Minus or add?
All these have to add up to 180,
Okay,
right?
you said subtract.
So you do 180 minus these two to get that.
145.
No. 180 minus 90 is 90. 90 minus 65 is
25?
25.
That's number
So I
27.
was trying to add 90 plus
Yeah.
65.
Okay, probably have to help on 22. Is angle DCZ equal to angle DCY? Do you guys see DCZ and DCY? How do we know they are the same?
Line segment DC is an angle bisector.
How do you know?
Because DY and DC, it cuts in half an angle.
No, it doesn't tell you that. We know it because D is on the, it's not the yeah, it is the in-center, I was wrong. D is on the in-center for BD and AD, so CD is a angle bisector. Because D is the in-center, CD is a bisector. You just say that.
What do you say?
Since D is the in-center, comma, BD must be an angle bisector.
C.
Or sorry, CD. Must be an angle bisector.
D is the center. Comma.
CD is an angle bisector. There's a segment bisector and an angle bisector.
Is it BD or CD?
CD.
Can you repeat it?
Oh my.
Since D is the in-center, it's on the angle bisector, then CD must be the angle bisector. Okay, 29 says XD equals and YD equals. What do you think we know about XD and YD? They are the same. So all that 3x minus 9 stuff must equal x plus 1 stuff. So 3x minus 9 equals x plus 1. What we're looking for, the question asks, find ZD. What do we know about ZD? It's going to be the same as those two. So if we can find the length of one of those, then we know the length of all three of those. So how do I solve this for x?
Subtract x, we'll get 2x, and subtract 9, then
Add 9.
then you divide by 2, then so if x equals 5, then you will just add 1, which means x equals
You get that, dude? Good job.
And then 5, right?
Well, that's not the answer.
Well, yeah.
That's not the extra conclusion, which is pretty easy because we only have an x plus 1.
Yeah, these two things are the same, so it doesn't really matter which one we plug it into. So if I just put 5 right here, then it must be 6 long, yeah. All right, that is it for the